Okay, good morning guys. Welcome sa subject natin for today, Review Mathematics, and today's lesson will be about the applications that we are going to discuss in differential calculus. Okay, so for this subject, since this is already a review subject, I will no longer um, get into detail dun sa mga differentiation formulas natin. Kasi I hope you still remember doing differentiation, especially yung mga basic differentiation natin and yung mga other differentiation natin ng halimbawa trigonometric, exponential, logarithmic. So, you could always pertain doon sa mga formulas natin kasi lahat naman yan is may particular formula siyang ginagamit, no? It's a matter of manipulation ng mismong function on how to simplify those functions so that we can easily differentiate them. For our discussion today, we will just focus on the application of differential calculus on three areas ng engineering siguro, no? So at the end of the session, here are our learning outcomes. So first is to strengthen yung knowledge natin sa differential calculus. And next is to enhance yung ability natin to analyze application problems in differential calculus. So bakit nag-focus ako sa application? Kasi based from my experience and based from review books na nabasa ko, okay? Uh, Kapag halimbawa differential calculus yung topic na binibigay, usually in terms siya ng word problem, which is application na siya, no? Kung may given man siyang hindi application or halimbawa differentiation siya ng function, may mga techniques na tinuturo ang mga review centers on how you can solve those functions using your calculator, no? So siguro I'll be referring na lang dun sa techniques nung review center yung pupuntahan once you graduate to teach you on the techniques on how to get the differentials of a given function using your calculator. Pero sa atin ngayon, ang tuturo ko is yung pag-analyze ng problem and applying yung differentiation formulas to solve what is required on the given problem. Okay? So, topics to cover natin. So, yung derivative applications na cover natin for today are maxima and minima, time rates, and I don't know if na-tackle nyo yung motion problems, pero I'm not sure kung na-cover siya, pero kasama natin yung motion problems. As practice na din, kasi dapat sa mechanics to kasama, pero I don't know kung ituturo siya sa mechanics nyo, sa review mechanics nyo, no? Kung meron man kaya. Okay, so let's start with maxima and minima. So sa maxima and minima, there are rules for solving it. Okay, so ito siguro yung steps na maganda alamin natin to follow para ma-solve natin yung given problem sa atin, no? First one is, once we read the problem, is to identify the quantity to be maximized or minimized. Kasi di ba sa maxima and minima, may hinahanap tayong maximum or minimum value dun sa problem. Kaya siya tinawag na maxima and minima. And we have to express that maximum or minimum amount or quantity into a term of single variable. Anong ibig sabihin? Kung yung makukuha mong equation is in terms of y at x, dapat gawin mo lang siyang in terms of one variable, no? In terms of x lang siya, or kung saan mo siya mas masisimplify into a single variable. Para once you differentiate it, isang variable lang yung ginagawa natin. Hindi tayo nag-i-implicit differentiation or nagsasabay ng nag-differentiate tayo ng dalawang variable at a time. Okay? Second, i-differentiate daw natin yung function determined in number 1 and equate natin yung derivative to 0. So once we get the first derivative ng function na nakuha natin, na gawa natin in terms of a single variable, i-equate natin siya sa 0. So bakit ni-equate sa 0? So para malaman natin yung as a rule para dun sa pagkuha ng maxima and minima, pag yung kung saan pag yung equation natin or yung slope natin is equals to 0, di ba, doon nag-horizontal yung value ng slope. So, may makukuha tayong um, answer from our unknown variable. Okay? Then, third one is solve natin yung values of the variable and check whether they maximize or minimize the given quantity. So, paano natin malalaman kung nagma-maximize talaga o nagbi-minimize yung nakuha nating value? Kasi yung makukuha nating value once we equate to 0, tatawagin natin siyang critical number, no? Yung critical number na yun, kailangan i-test natin kung talagang mag-maximize siya o mag-minimize siya. So, paano siya makukuha? Kailangan kukunin mo yung second derivative. Anong isa second derivative mo? Yung equation na nakuha mo sa number 2. So, second derivative test. So, once your second derivative, tapos sinubstitute mo yung nakuha mong critical number sa number 3, is nag-less than 0, ibig sabihin niya maximum tayo. Pag nag-greater than 0, ibig sabihin minimum. And then kapag nag-equal sa 0, test fail, ibig sabihin you have to recheck your equation or baka may mali kayo sa analysis na ginawa niyo. Okay? So, to appreciate more itong mga words na nandito, you have to put it on in example para mas maintindihan siya. Okay? Okay, ito yung question natin for the first one, application. So, Mrs. Reyes wants to plant along a rectangular garden in front of her house where 3 sides need fencing. Find the dimension of the largest garden that can be enclosed using 40 feet of fencing. So, yan yung tanong. So, anong hinahanap? So, di ba, sa number 1, dito sa ano natin, identify daw natin yung quantity to be maximized. Okay? So, kuha ko ng copy nito para may guide tayo sa problem natin. Okay. Yeah. So, yung sabi doon sa first one, identify natin yung quantity to be maximized or minimized. So, ano ba yung problem? Sabi, si Mrs. Reyes gusto mag-plant along a rectangular garden in front of her house. So, halimbawa, ito yung bahay niya. Okay? Plan view tayo ha. Nasa, ano tayo? Sabihin naka-top view tayo. Ito yung bahay niya. Sabihin natin, itong side na to, ito yung front ng bahay niya. Okay? Sabi, gusto niya mag-plant sa rectangular garden. Okay? So, yung rectangular garden na yun, yan. So, mula doon sa front ng house niya, gagawa siya ng fencing na 3 side para magkameron siya ng rectangular shape na garden. Okay? Tapos, kailangan yung 3 sides na yon may fencing siya. Ang pinapahanap yung dimension ng largest garden na pwede niyang ma-enclose. Okay? So, ibig sabihin, largest area na possible yung makuha. So, sa number 1, dito, sa identify the quantity to be maximized, ang gusto niyang ma-maximize ngayon is yung area of rectangular garden. Okay? And isipin mo na agad, area ng rectangle na garden. So, pag area ng rectangle, ano ang formula ng area ng rectangle? Okay? So, area ng rectangle is equals to length times width. Okay? So, length times width. Okay, dito sa given natin na figure, kailangan maglagay ka ng, assume ka ng variable sa kanya. So, assume natin na yung horizontal o itong side na to is x, no? Kasi along horizontal direction siya. And then itong anong to, side na to is y. Okay? So, kung makikita ninyo, para maging rectangle yan, dapat yung left side and right side, dapat equal siya ng quantity, no? Hindi naman pwedeng, sa figure, mukha lang siyang hindi equal, no? Kasi yung pagkakascale niya. Pero dapat kung rectangle siya, yung 2 opposite sides are equal. Okay? So, yan. So, ngayon, anong given? Ang may given tayo na yung fencing daw na pwede niyang i-enclose is 40 feet. So, ano yung 40 feet na yun? Yun yung haba ng fencing na pwede niyang ilagay dito. So, ano ibig sabihin? Yun yung kanyang perimeter. Okay? Yun yung perimeter na ilalagay niya dito. Kasi ito, di man natin ito pwedeng bakuran kasi ito yung front ng bahay niya. So ito yung fencing na gusto niyang ilagay doon sa bahay niya, no? Doon sa harap ng bahay niya para ma-enclose yung garden na tina-target mo. So yung area of rectangular garden mo will be, kung length times width tayo, so x times y lang tayo. Yan yung area natin. Yan yung ima-maximize natin. Pero sabi nga sa number 2 dito, kailangan, ay sa number 1 pa din, kailangan in terms siya ng single variable lang. Okay? Dito ang variable mo, x at y. So kailangan dapat in terms of x lang siya. So saan mo kukunin ngayon yung relationship na bago? Kunin mo dun sa perimeter mo, which is ito. Nakalagay sa kanya 40 feet ng fencing. Okay? So yung 40 feet na yon, saan magiging equal yon? Kunin natin muna yung perimeter. So ang perimeter, di ba, is summation ng sides. So ito yung side natin. So ibig sabihin niyan ay y plus x plus y, or equals yan sa perimeter equals to x plus 2y. Okay? Tapos may given naman na yung length nung fencing na yon o yung perimeter na yon ay 40 feet. Okay? So 40 is equals to x plus 2y. So kung ito yung kailangan mong i-maximize na equation, kailangan kumuha ka ng value ni y mula dito sa second equation na nakuha mo or relationship na nakuha mo. Okay? Makukuha ba natin yung y? Yes, by transposing tsaka dividing yung both equation by kung ano man coefficient yung meron si y. So this will be 2y is equals to 40 minus x. Divide natin both side by 2. So we have y is equals to 20 minus 0.5x. Okay? So ito yung value ng y na pwede mong i-substitute dito sa y mo dito. Para yung equation mo ng area is maging single variable lang. Okay? So, lagay ko lang ito dito. Okay. Okay. So, kung may nakuha tayong variable na y, so pwede nating substitute ngayon yung dito. 20 minus 0.5x. So, meron tayong area is equals to 20x minus 0.5x squared. Okay? Ngayon, check mo ulit. Is our equation equivalent to a single variable? Yes, no? Kasi in terms of x na lang siya. CA, sasabihin mo, bakit po CA hindi sinabing variable? CA is area. So, once nag-derive tayo, si area is a quantity. So, any, di ba, inaano natin na pag constant yung value, yung derivative ng constant is equals to 0. Okay? So, ang variable lang natin dito is si x na lang. Okay? Ngayon, si number 2 tayo. Differentiate daw natin yung function and equate the derivative to 0. So, ang di-differentiate natin ito. Okay? So, pag dinerive natin yan, a prime is equals to 20 minus 1.0 x. Okay? Question kung bakit naging ganun yung derivative?
Wala po.
Nakakahabol naman na kung bakit naging ganun yung derivative, ha? And then once daw na kuha natin yung derivative niya, i-equate natin siya sa 0. Okay? So, ibig sabihin, ito magiging 20 minus x is equals to 0 or x is equals to 20. Yan. Ngayon may nakuha tayong value ni x. So, yung x na yun, ito yun. Ngayon, ito yung tatawag natin critical number. Okay? Critical number siya kasi kailangan natin siyang i-check kung talagang i-maximize niya yung problem natin o yung quantity gusto natin i-maximize. So, punta tayo sa number 3. Si number 3, sabi niya, solve for the values of the variable and check whether they maximize or minimize. Para daw natin ma-check yun, kailangan natin kunin yung second derivative ng function. Okay? Ito yung first derivative natin. Kukunin natin yung second derivative niya. Okay? So second derivative nun will be a double prime is equals to 0 minus 1. And kapag simplify natin, that is negative 1 and negative 1 is less than 0. Anong nakalagay dito sa conditions natin? Kapag si second derivative is less than 0, ibig sabihin yung function natin is maximum. Which is, yun yung hinahanap natin kasi largest garden yung hinahanap natin. Therefore, yung x is maximum. Okay? Nangyari lang na yung function natin is wala na siyang x na variable. Kaya hindi na natin kailangan mag-substitute ng value. Pero if ever yung second derivative natin is may x na value, ang sa-substitute nating value dun is yung nakuha natin critical number. Okay? O yung value na nakuha natin sa step 2. So once na consider na verify natin na maximum siya, pwede na natin tuloy yung problem and get the another quantity. So meron nakuha tayong value na x is equals to 20. So para makuha si y, substitute mo lang siya dito sa na-derive mong equation. Okay? So is equals to 20 minus 0.5 ng 20. So this will be 20 minus 10 or y is equals to 10. Okay? So ibig sabihin, ito daw ay 10, ito ay 20, ito ay 10. Ngayon ang tanong, find the dimension. Okay? Dimension ang hinahanap. Okay? So anong pinaka-final answer natin? Pag dimension ang hinahanap. So kung dimension ang hinahanap, ito ay A is maximum pala. Okay? So kung dimension ang hinahanap, so yung size niya. So kung paano ba nire-refer ang dimension ng rectangle? Length times width pa din. So ang dimension natin will be 20 by 10. So this will be our answer for our first problem. Okay? So may unit pala yon. So lagyan natin ng unit. 20 feet by 10 feet. Okay? So to arrive with the greatest or largest garden, kailangan yung dimension natin is 20 by 10 feet na rectangular garden. Okay? Question for number 1.
Wala po.
Okay. Next. Okay, so a printed page must contain 200 square inch of printed matter. There are margins of 2 inch at the sides and 4 inch for each top and bottom. How long should be the printed lines be in order to minimize the amount of paper used? Sige, lagay ulit natin ito dito as a guide. Okay? So, number 1 kailangan analyze natin problem. We have a printed page na kailangan mag-contain siya ng 200 square inch na printed matter. So, meron tayong paper, no? Okay. Yan yung paper natin. And then meron doon tayong printed matter sa kanya na 200 square inch. May binigay na margin. So 2 inch sa side. So okay. So sabi, meron siyang margin na 2 inch dito. 2 inch dito. And then sa top and bottom natin 4 inches. So ito ay 4. Ito ay 4. Okay? So yung printed matter natin is ito 'yon. Itong portion na 'to. Yan yung kumbaga may text yan. Yan, ito yung areas natin na may text. Okay? Ngayon, anong pinapahanap? So number 1 is how long should be the printed lines be in order to minimize the amount of paper used? Kailangan i-minimize natin yung amount paper used. So kung yung amount ng paper used, yung mi-minimize natin, ano yung kino-consider natin? Dapat yung size nung page natin in general. Okay? So ibig sabihin yung pinaka-size niya. Kung ito Yung horizontal niya, tawagin natin x. Ito, tawagin natin y. Okay? So, sa number 1, ang hinahanap natin is, again, yung size niya. So, parehas dun sa rectangular garden. So, para ma-minimize yun, kailangan natin ng area. So, area is equals to x times y. Okay? Then next, kuha tayo ng relationship. No? So, ito ay area ng paper to. Tawagin kong AP. Okay? Ang may given sa atin is area ng printed matter. Okay? 200 square inch. Alin ba yon? Ito yon, yung may kulay green. Ano ba yung dimension ng kulay green? So, based sa figure, would you agree na ito ay y minus 8? Okay? And then ito, x minus 4. Okay? So, yung area ng matter is equals to x minus 4 times y minus 8. And then given 200 square inch siya, is equals to x minus 4, y minus 8. And then kailangan natin is value for y para sa substitute natin dun sa given natin dito. So para makuha yan, divide natin both side by x minus 4 para mag-cancel out to. So magiging y minus 8 is equals to 200 over x minus 4. Then y will be equals to 200 over x minus 4 plus 8. So ito yung value ni y na pwede natin i-substitute dun sa first equation natin to make our equation in terms of one variable lang. Okay? So, substituting, so AP is equals to x times 200 minus x minus 4 plus 8. Okay? Simplify natin. This will be 200x over x minus 4 plus 8x. So, para dun sa number 1, ito na yung kailangan natin na equation. Okay? Next, number 2. Sa number 2 is kailangan natin siyang i-derive. No? So, ito ang de-derive natin. Again, please go back sa basics nyo ng derivative. No? Okay. Palitin ko lang to. Okay. So, sa number 2 natin, kunin lang natin yung derivative nun. So, that will be AP prime is equals to derivative ng quotient is anong formula nun? Well, pag u over v is equals to v du minus u dv over v squared. Yun yung formula para sa quotient. Okay? So, assign lang natin as u and v. So, ito yung u natin, ito yung v natin. Okay? So, udv, vdu minus udv. So, v, tapos derivative nung taas, 200, minus udv, 200x, times yung derivative ng baba, which is 1, all over derivative nito. Squared nung ilalim. Okay? Plus 8. Simplify. AP prime is equals to 200x minus 800 minus 200x all over x minus 4 squared plus 8. Simplify. AP prime. So, cancel natin to. So, this will be negative 800 all over x minus 4 squared plus 8. So, ito yung first derivative mo. Sabi, equate mo siya sa 0. Okay? Okay, so once na-equate mo sa 0, kailangan identify mo yung value. So, negative 800 over x minus 4 squared plus 8 is equals to 0. Multiply natin both side by x minus 4 squared. So, negative 800 plus 8, x minus 4 squared is equals to 0. So, negative 800 plus 8. So, x squared minus 8x plus 16 is equals to 0. Simplify. Plus 8x squared minus 64x plus what is 16 times 8? 128 is equals to 0. Simplify ulit natin. 8x squared minus 64x minus 800. So, minus 672 is equals to 0. So, divisible by 8 yung lahat ng function. This is x squared minus 8x minus 84 is equals to 0. Ngayon, kunin mo ngayon yung factor mo. So, balik kayo sa algebra o kaya gamit kayo ng ano no? Ah, ng anong formula to? Quadratic function. So, quadratic function natin, x equals to negative b plus minus square root of b squared minus 4ac over 2a. So, sa-substitute natin, negative b plus minus, substitute na natin. Negative 8 plus minus square root of negative 8 squared minus 4 times 1 times negative 84. Kasha. Okay? Kaya lahat nagsasama-sama na, no? From algebra hanggang ano. Okay? Negative 84 all over 2 times 1. Okay? Pan-solving, may makuha tayong value ni x1 and x2. Okay? So, kunin ko lang muna yung isa. Negative 8. So, negative 8 plus muna square root of 8 squared minus 4 times negative 84. Lower 2 times 1. So, that is x1 is equals to 14. And then, kapag minus siya, negative 6. Okay? So, may nakuha tayong x1 is equals to 14 and x2 is equals to negative 6. Pero, kailangan i-analyze mo. Dalawa yung nakuha mong value, pero dimension yung hinahanap natin eh. So, sa dimension, possible ba magkameron ng negative number? Hindi, di ba? So, yung isang value ng x na negative, i-disregard mo na siya. Okay? So, ibig sabihin, disregard mo to. Kasi walang dimension na negative. So, si x1 lang yung gagamitin mo. And ngayon, meron tayong critical number. Ito na yung critical number natin. Kailangan kunin natin yung third one, which is yung second derivative ng function natin. So, alin yung function na tinutukoy natin? Ito. No? Second derivative niyan. Okay? So, pag hindi tayo marunong mag-derive, problema sa atin yan. Okay? So, second derivative ko sa next slide na lang. No? So, ito yung first derivative. Negative 800 over x minus 4 squared plus 8 is equals to 0. Okay? Kunin daw natin yung second derivative niyan. So again, derivative ng quotient is just yung formula natin. Okay? Na u over v, v du minus u dv over v squared. Okay? So dito, ang u natin ngayon is yung negative 800. Ang v natin is ito. Okay? So v du, so v plus du natin is constant, so 0 to, minus negative 800. Then derivative nung, sorry. So na yun. Okay? Derivative ng denominator, that is 2 times x minus 4 times 1. Okay? And then squared ng ilalim, x minus 4 to the 4th. Okay? Simplify natin. This will be 1,600 x minus 4 over x minus 4 to the 4th. So yung plus 8, 0 na siya, no, kasi constant. So cancel natin yung isa. So this will be cube. So this will be 1,600 over x minus 4 cube. Ito yung second derivative natin. Okay? Once nakuha natin yung second derivative, sa-substitute natin yung critical number natin. So yung critical number natin dito is yung 14. Okay? Substitute natin yung 14. So 1,600 divided by 14 minus 4 cube is equals to 1,000. Nangyari. So 1,600 all over 10 cube. So 1/6 over 10 cube is how much? 10 cube by 1,000. So na yan. Okay. 10 cube. So this is 1.6. Okay. Which is greater than 0. And anong sabi pag greater than 0? Siya ay minimum. Okay. Which is yun yung kailangan natin sa problem. I-minimize natin siya. Okay. Therefore, yung area ng printed matter natin is minimum kapag ginamit natin yung value na 14. Okay? So meron na tayong value na x is equals to 14. Okay? Kukunin natin yung value ni y. So y is equals to 200 minus x minus 4 plus 8. So this will be 200 over 14 minus 4 plus 8. So 200 all over 10 plus 8. So this will be 20 plus 8 is equals to 28. Therefore, yung hinahanap natin is how long. So ibig sabihin yung vertical dimension ng paper natin. Vertical dimension ng paper natin pertains dito sa y. Okay? So how long ang tinatanong, so dapat ang sagot natin 28 inches. Okay? So yun yung sagot natin for this problem. Okay? Question?
Wala po, sir.
Okay. Sana nakakasunod pa, no? Ganun talaga sa application, no? Kailangan yung basic knowledge natin dun sa derivative and algebra are all intact, no? Lahat sa ginagamit. Okay? Next. Sige, discuss ko na din to. Okay, so a box is to be made from a piece of cardboard 9-inch square by cutting equal squares out of the corners and then turning up the sides. Find the volume of the largest box that can be made in this way. So, paano daw ba yung nangyayari? So, meron daw tayong piece of cardboard, no? Ayan. Yan yung cardboard natin. Ang size niya, 9-inch by 9-inch. Okay? Kasi ang mangyayari daw, magka-cut daw tayo ng equal squares dun sa sides niya. Dun sa corners niya. Okay? So, ito yung isang square. Ito yung square. Ito yung square. Okay? So, equal squares yan. So, square yan. So, ibig sabihin, yung dimension ng side niyan is the same. Okay? Pagka-cut down natin nun, ita-turn natin yung sides para makapag-create tayo ng box. Okay? Paano yung itsura ng box? So, ito, kapag tinupi natin, okay? Para siya magiging okay, yung ganito. Okay? So, tinupi natin yung side. So, open yung top, tapos yung ilalim. Ito. Okay? So, ano yung size na hindi natin alam yung kinat natin na dimension, no? Ang pinapahanap, volume ng largest box. Okay? So, ibig sabihin, volume nitong picture na to. Okay? Yung cube natin, kung square siya, no? Kung square pa din yung dimension niya. Okay? And paano natin makuha ang dimension or volume ng ganyan? Volume ng box o ng cube? Anong formula?
E cube.
Okay? Kung cube siya, kung given na equal yung each side, yes, tama, no? Kung halimbawa rectangular parallelepiped naman siya, is yung 'di ba length times width times height, no? Again, kung equal siya, pwede siya dun sa yung side cube. Okay? So, kailangan kunin natin yung dimensions. Okay? So, kung halimbawa ang size nung kinat natin na corners ay na squares ay x by x, since square nga siya. So, ano 'yan? Okay? So, ano magiging dimension ngayon nung mga sides natin? So, itong ilalim natin na to na portion. So, okay? So, sa figure natin na 3D, ito 'yan. Okay? So, ano yung size niyan? So, kung 9 yung dimension niya, kung 9 yung kabuuan niya, this will be 9 minus 2x. Okay? Same with dito, this will be 9 minus 2x kasi 9 din to. Okay? So, ibig sabihin yung dimension nito, 9 minus 2x, 9 minus 2x. Okay? Ngayon yung thickness niya. So, ito yun. No? Pag tinupi natin, ito yung naka-vertical. No? Lagyan ko ng kulay para hindi tayo malito. Okay? Ito yan. Okay, yan. Okay? So, kung x yung value niya nung hindi pa natin tinutupi, definitely yung value niya, pag nakatayo na siya, x pa din. Okay? So, para dito sa figure na to, ano yung length, ano yung width, ano yung height. Okay? Yung length natin is ito, yung width natin ito, yung height natin is ito. Okay? So, pag kinuha natin, volume is equals to 9 minus 2x times 9 minus 2x times yung height natin na x. Okay? Okay, so yan na yung nakuha nating formula. So mapapansin mo, in terms ng one variable na agad siya. Okay? So, pwede na natin siya agad mag-step 2 na agad tayo, mag-differentiate na agad tayo. Okay? Pero maganda kung mas simplify natin. Ito pwede siya maging 9 minus 2x squared times x. Or pwede na natin i-distribute na lahat, no? So, yung binomial magiging siyang 81 minus 36x plus 4x times x, x squared to. Tapos pag sinimplify, 81x minus 36x squared plus 4x cubed. Okay? Sinimplify ko para mas madali siyang i-derive. Okay? Kasi pag dinerive mo siya, derivative ng power lang siya. Okay? So sa number 2, kunin natin yung first derivative niya. This will be 81 minus 72x plus 12x squared. Okay? Tapos equate daw natin sa 0. So lahat ba is divisible by 12? So tingnan natin. Hindi, no? 72 divide 12 is 6. Okay, so pag dinivide natin lahat by 12, 81 divide 12, so that is 6.75 minus 6x plus x squared is equals to 0. Okay? So performing ulit yung ano natin, quadratic equation. So hindi ko na ipakita, no. May makukuha tayong value na x1 is equals to 4.5, x2 na may value na 1.5. Okay? So parehas positive. Ngayon, i-check mo ngayon kung alin dyan yung gagamitin mo. So dalawang critical number mo, pero ang kailangan natin is largest box. So kailangan tayo ng maximum. So kailangan pag kinuha natin yung third step, yung maximum value ang i-consider natin. Okay? So sa third step natin, kunin natin yung second derivative ng volume natin. So, yung first derivative natin is equal sa um, x squared minus 6x plus 6.75. Okay? Yung second derivative niyan is 2x minus 6. Okay? And may value tayo na x is equals to 4.5 and x is equals to 1.5. Okay? Kailangan substitute natin yan parehas. So, dito sa una, pag sinubstitute natin siya na 4.5 minus 6, b prime natin is equals to 3. Okay? Dito, this will be negative 3. Okay? Ito is greater than 0, ito ay less than 0. Anong kailangan natin? Kailangan natin is maximum. Okay? So, mula dito, maximum yung kailangan natin. So, kailangan greater than 0 tayo. Maximum tayo, so dapat less than 0. So, alin ang less than 0? Ito. So, ibig sabihin ng kailangan nating value is, o gagamitin nating value is si 1.5. Okay? So, once na na-identify natin na si 1.5 yung magbibigay ng maximum value, kunin natin yung volume. Okay? Volume is equals to yung equation natin. So, 9 minus 2x squared times x. Substitute natin. 9 minus 2 times 1.5 squared times 1.5. Yung volume natin will be equals to 9 minus 2 times 1.5 squared times 1.5. Okay? This is 54 unit natin inch cube. Therefore, ito yung largest volume na makukuha natin given yung dimension na yan. Okay? So, ayan. So, hindi sapat na makuha mo yung critical number. Kailangan ma-identify mo kung alin yung nagbibigay ng maximum and minimum. Sa board exam, nangyayari yan, no? Na nasa choices, si 4.5 tsaka si 1.5. Umasa ka sa shift solve. Nag-shift solve ka nung function. Ito, shift solve mo. Sa shift solve mo, ang lumabas ito, 4.5. So, mali ka na kaagad. Okay? So, be careful sa paggamit ng shift solve. So, to be sure dun sa answer natin and to get yung value ng x na dalawa kapag quadratic tayo, use quadratic formula. Okay? Okay? So, yan yung sa Maxima and Minima. Yan lang siguro yung pinaka-basic na pwede kong ma-share na technique kung paano nyo siya masosolve correctly. Okay? Next, punta tayo sa time rates. Sa time rates naman, ito yung steps in solving time rates. So, identify natin ano yung nag-change or yung varying and what are fixed. Then, assign natin yung variable to those that are changing and appropriate value, constant, dun sa mga fixed. Tapos, create tayo ng equation relating yung variables and constant sa step 2 and next is differentiate natin yung equation with respect to time. Okay? So, si time rates nangyayari siya kasi dahil yung buong equation natin, kahit madami siyang variable, diniderive natin siya in terms ng time. Kaya nga siya time rates. So, ibig sabihin, yung derivative natin, bawa x, dx over dt. Then si y, dy over dt. Okay? So, again, copy natin to and apply natin sa example. Okay. Okay, first example. Water is flowing into a conical reservoir, 2 feet deep, 10 feet across the top at the rate of 15 cubic feet per minute. Find how fast the surface is rising when the water is 8 feet deep. Okay. So, may conical reservoir tayo. Okay, paano itsura niyan? So, may cone tayo. Okay. Yan. And then water is flowing. So may maagos sa tubig, no? Ang dimension niya 2 feet deep. Okay. So medyo i-scale natin. Mali pala yung scale ko. Okay. 2 feet deep tapos 10 feet. Okay. Yeah. So 2 feet daw to. Tapos 10 feet across the top. So yung diameter niya is 10 feet. Okay? And yung rate daw ng pag-flow, no? Yung rate ng flow ng water, yung pagpunta ng water dun sa ano natin is 15 cubic per minute. Find how fast the surface is rising when the water is 8 feet deep. Okay. Ayan. So identify natin what are changing and what are fixed. Okay? So may given, 'di ba, may nagfo-flow na water. Ito si water. Okay? So kung continuous yung flow ng tubig, ibig sabihin nagche-change yung height ng water dun sa loob ng reservoir natin. Okay? So ibig sabihin nagbabago yung height natin tsaka yung diameter ng water dun sa loob. Okay? Ang hindi nagbabago is yung dimension ng mismong reservoir natin. 10 feet siya, yung diameter ng mismong top, and 2 feet deep siya. Okay? So kung titingnan natin sa sa elevation, ganyan yung itsura niya, no? Ito is 2 feet. Ito is 10. Okay? So ngayon ang pinapahanap is how fast is the surface is rising. Okay? Yung rate ng pagtaas nung height ng water. Ibig sabihin. Okay? Kasi ito yung surface ng water natin. So para mahanap yung rate ng pagtaas niya, kailangan yung pagbago nung mismong y direction natin. Okay? So kung halimbawa ito yung water natin, yan, assume natin siya na y yan. Okay? And then yung kanyang diameter or radius na lang, tawagin natin x. Okay? And then dito, yung radius natin dito is half lang naman ng diameter natin. Meron tayong 5. Okay? So, anong formula ang pwede natin gamitin? Alam natin cone yan. So, ano bang formula ng cone? Mula sa solid geometry natin. Anong formula ng cone? Volume ng cone.
4/3. Tama.
1/3. Tama ba?
1/3 BH.
1/3
BH.
base times height, di ba? Base times height. So, volume is equals to 1/3 ng base natin. Ang base natin is a circle. So, pi r squared h. Okay? So, dito yung h natin is given naman siya, no? Okay? So, identify what are changing. So, ang nag-change natin is si y and si x, no? Ang fix natin ay si h, ang fix. Okay? So, ibig sabihin si radius nagbabago. Si x ay yung radius natin, di ba? Okay? And si height, nagbabago din pala si height. Sorry. Ito. Okay. Pero ngayon, pwede tayo makakuha ng relationship dun sa mismong diagram natin. Meron tayong triangle. Okay? So, meron tayong x, meron tayong y, meron tayong 2.0. Ito yung h natin. Okay? And then meron tayong r. Ito yung radius natin. Okay? So, kuha tayo ng relationship. So, 2.0 over 5 is equals to y over x. Okay? So, iangkop natin doon sa formula na lang pala. So, wag ng x and y ang gamitin ko. R and h na lang gamitin ko. R tapos h para hindi tayo nalilito. Okay? So, ito 5. So, ito yung R, ito yung h. So, R over H over R pala to. H over R. Okay? So, si volume natin, ayan, na-identify natin na si R and H are changing. Okay? Kasi once na nag-rise yung surface ng water natin, magche-change siya ng value. Number 2, assign variable to those that are changing. So, meron na. Number 3, create an equation relating all the variables. Okay. So, ito yung relationship ng H and R. So, pwede natin makuha yung value ni R and ni H para substitute natin doon sa volume. Pero ano ba yung given sa atin? Meron tayong change in volume. Tapos ang hinahanap sa atin is pag pag-change ng surface. Okay? Ito is yung pag-change ng volume with time. Tapos how fast is the surface is rising. Yung surface is rising, ito ay yung dH over dt natin. Okay? Ibig sabihin, kailangan in terms ni H yung equation natin. So, para mag in terms of H, magigitong 2.0 over 5 times R or 2 divide 5. 2 divide 5 is 0.4. 0.4 ng R. So, substitute natin dito. 1/3 pi. Ang kailangan natin si H. So, kailangan pala si R ang sa-substitute na baliktad. Okay? So, dapat ito is H. Pwede natin pagbaliktarin. Gawin natin R over H is equals to 5 over 2 or R is equals to 2.5H. Okay? So, si R yung sa-substitute natin dito. So, 2.5H squared times H. This will be 1/3 pi. 2.5 squared is 6.25. H cube na. Multiply ko na yung H. Okay? And divide natin ng 3. So, volume natin will be equals to 2.083 pi H cube. Okay? Ngayon, in terms na siya, ito na yung number 3 natin. Differentiate na natin yung equation. Pag din-differentiate natin yan, this will be, in terms ng t, dv over dt. And then ito is constant, so gagayahin mo lang. 3 pi times 3 h squared. dH over dt. Kasi in terms ni h. Okay? Simplify. dv over dt is equals to 2.083 pi times 3. That is 19.63. H squared dH over dt. Ngayon, ito yung equation natin. Ano ngayon kailangan natin substitute? Si dv dt meron ba tayo? Si dv dt is ito. 15. Meron tayong value. Si H, meron ba tayo? May given na 8 feet deep initially. Okay? So, ito yon si H. So, dH dito yung hinahanap natin. So, that will be copy natin. Okay? Ayan. So, substitute natin. So, this will be 15 is equals to 19.63 times 8 squared dH over dt. So, para makuha yung rise, yung rate ng pag-rise ng surface o yung change ng height, That will be 15, divide natin na 9.63 times 8 squared. Or nagra-rise siya ng 0.012 feet per minute. Okay? So, ito yung magiging answer natin for the given problem. So, yun yung change ng height ng surface ng water dun sa loob ng conical tank natin. Tama bang pag ano ko? So, 15 double check natin, no? So, R5 H2 so 5 2.5. Okay? So, yan po. Okay? Question? So, balikan ko nga lang to ha. So, 1/3 times pi times 6.25 6 point, ayan. Hmm, 2.083 times pi times 3. Unit natin, consistent naman. Okay? So, yan yung answer natin. Next. Yan. So, a boy on a bike rides north 5 miles and then turn east. If he rides 10 miles per hour, what is the rate? Was his distance to the starting point? S changing after 2 hours after he left that point. Okay? So, ano yung nangyayari? Meron tayong starting point. No? Dito siya nag-start. Nag-travel siya ng north. Okay? 5 miles. And then, nag-turn siya ng east. Okay? So, hindi sinabi kung tumigil, no? If he rides 10 miles per hour, okay? Ano yung 10 miles per hour? Ito yung kanyang speed, no? At what rate his distance to the starting point is changing 2 hours after he left that point. So, 2 hours after he left that point. Okay. So, halimbawa ito yung nung tinanong yung problem, ito na yung position ng boy. Ngayon, mula doon sa starting natin and location niya ngayon, ang tinatanong is at what rate his distance to the starting point, so itong distance na to, okay, is changing 2 hours after he left that point. So, 2 hours after siyang makaalis dito. Okay? So, kailangan hanapin natin yung rate ng pag-change nito. So, halimbawa habang pumupunta siya pa is, ano yung rate ng pag-change ng distance na yun mula doon sa starting point niya. Okay? So, dito sa figure natin, ano yung nagawa natin? A right triangle. Okay? So, kung right triangle yan, may makukuha tayong relationship lagi dyan. Okay. May given siyang speed na 10 miles per hour. 5 miles yung distance nito. Itong distance na to, hindi natin alam. Okay? So, yung distance na yun, tawagin natin x. Hindi natin alam eh. Okay? Pero anong pwedeng formulang mano natin kapag speed ang pinag-uusapan? Di ba? Speed is equals to distance over time. Okay? So, speed is equals to distance over time. So, kung gusto natin hanapin si distance, yung speed times lang natin ng time. Okay? So, kailangan check natin. Yung 5 miles, para makarating siya dito sa point na to, ano yung time bago siya makarating doon sa point na yun. Okay? Sorry ulit. Okay? So, that is, yung distance natin na 5 miles. So, distance equals to speed times time. Kailangan natin si time. So, distance over speed. So, 5 miles over 10 miles per hour. Okay? So, 5 divide 10 is 0.5 hours. Okay? So, ibig sabihin dito, 0.5 hours na yung na-cover niya. Eh, sabi 2 hours after nung nag-lap siya nung point na yon. So, ibig sabihin, itong location na tinatawag natin na to, ito yung kanyang location, 1.5 hour. Okay? So, ano yung magiging value natin ng x o nung distance natin na yon? So, distance over time, distance equals to speed times time. Distance is equals to 10 miles per hour times yung time natin sa kanya na 1.5 hour. Okay? Pero nag-change siya, so hindi natin alam. Okay? Okay. So, tawagin natin S to. So, total distance, okay. Okay. Sige, analyze natin yung total distance niya. So, sabihin natin yung itong distance na mula dito sa location na to, papunta dito, ano yung distance na yon? 5 plus x. Okay? And then, ito yung distance. Yung speed natin is 10 miles per hour. Yung time natin is kailangan makakuha tayo equation eh. Kasi itong distance na to nagche-change siya, so kaya hindi natin pwedeng i-fix yung 1.5. Okay? So, kailangan natin gawin is ano ba? Magkuha tayo ng relationship nung sa distances natin. Okay? So, again, yung 10 miles natin is speed equals to distance over time. Speed is equals to distance over time. So, speed natin 10 miles. Distance natin from starting dito sa location is 5 plus x. Tapos, over time. Hindi natin alam yung time. So, gawin natin tong 10t is equals to 5 plus x. Therefore, pwede natin represent na si x is equals to 10t minus 5. Okay? Kung may right triangle tayo, anong equation natin? Kung may right triangle tayo. So, kung may right triangle tayo, that is s squared, yung hypotenuse natin, is equals to yung 5 miles plus x squared natin. Derive natin in terms ng time. Pero kailangan, no? So, pwedeng substitute na natin yung value ng x kasi may na-calculate tayo. S squared is equals to 25 plus 10t minus 5 squared. Okay? Then, derive natin, this will be 2s ds over dt is equals to 0 plus 2 times 10t minus 5 times 10. Since yan ay in terms ng t, hindi na kailangan ng dt over dt. Simplify, we have 2s ds over dt is equals to 20 times 10t minus 5. Okay. Anong pwede natin gawin ngayon? So, nung si t is equals to 2 hours, kailangan kunin natin yung value ni x. Okay? So, after 2 hours, kailangan kapag ano tayo ng fix na ma-substitute na fix na number sa kanya. Okay? Kasi ang kailangan natin is itong rate na to. Okay? So, ano yung value na yun? So, Kung nagra-ride siya ng 10 miles per hour, so given natin kung after 2 hours, 1.5 to, magiging na tong 15 miles yung na-travel niya dito. So para makakuha tayo ng value ng S, so 5, 15, tapos S, that is S squared is equals to 5 squared plus 15 squared. So S squared is equals to 5 squared plus 15 squared. Square root nun is 5 square root of 10. So itong value ng S na yon, dito yan lalagay. Okay? Yung value ng T dito, ano yung ting ilalagay natin? Yung value na after 2 hours. No? So 2S, yung S natin is 5 square root of 10 ds over dt is equals to 20 times 10 times 2 minus 5. Okay? Simplify natin, makakalculate natin yung value na ds over dt is 20 times 20 minus 5 all over 2 times 5 square root of 10. Makukuha tayong value na 3 square root of 10 or 9.47 miles per hour na rate ng pag-change nung distance nung current position nung bata mula dun sa starting position niya. Okay? Question? Okay? Wala na ako kausap. Okay? Thank you. It's already time, no? So, I think, sige, isagutin lang natin to. Madali lang tong last problem for time rates. Yung motion problem, i-upload ko na lang as additional recording, no? Okay. So, let's have our last problem. So, if x cubed and x increases at the rate of 3 units per second, how fast is the slope of the graph changing when x is equals to 5? Okay? So, may function tayo na y is equals to x cubed. Ang sabi, si x daw is nag-change, no? At the rate of 3 units per second. So itong change na to na tinutukoy na to, ibig sabihin, yan ay dx over dt. Okay? And hinahanap is how fast is the slope. Ang slope is laging in terms ni y, no? Na variable. So kapag dinerive natin to, this will be dy over dt is equals to 3x squared dx over dt. Okay? Ngayon pinapahanap, what is the slope? Yung slope na yun is ito, dy over dt. And then, dx dt natin given when the value of x is equals to 5. Okay? So, substitute lang natin. So, dy over dt is equals to 3 times value daw ng x is 5 squared and dx dt natin is 3 units per second. Okay? So, dy dt natin, pag sinimplify natin, that will be 9 times 25. That is 225. So, ito yung magiging ano natin, pag-change ng slope. So, ang unit nito is unit squared, unit per second, unit per second din, no? Okay? So, this will be our answer. Okay? Mas simple siya kasi direct lang yung derivative niya. Okay? And then, last application is we have yung motion problem which I will just upload na lang later on. Okay? Question?
Wala po.
Okay. Consistent si Miss Alia. Okay.